Ellipses. An ellipse is a focus of points in a plane that are each the same total distance from two fixed points, called the foci, the plural of focus. For example, P1, F1, so this length here, plus P1, F2, this length here, added together equals P2, F1 plus P2, F2. The eccentricity of an ellipse is a number between 0 and 1. The more elongated the ellipse, the closer the eccentricity is to 1. The closer an ellipse is to being a circle, the closer the eccentricity is to 0. The minor axis, CD, is perpendicular to the major axis through the center O. The major axis, AB, is the segment through both foci whose endpoints are on the ellipse. The vertices of an ellipse are the endpoints of the major axis and points A and B. The co-vertices are the endpoints of the minor axis, points C and D. Here we have a horizontal ellipse and a vertical ellipse. Here we have the center. We have the major axis that connects the vertex to the center to the other vertex. We have the minor axis that connects the co-vertex up here to the center to the other co-vertex, and we have our two foci. Here it's vertical, so it's all of the same parts, but just flipped on its side. The length of the major axis is 2a, the length of the minor axis is 2b. Here we have the standard form of a horizontal ellipse and the standard form of a vertical ellipse. All that has changed here is we've swapped the a and b's. So we have x minus h squared over a squared plus y minus k squared over b squared equals 1. For the horizontal ellipse, we have the center at h comma k. The horizontal distance from the center of the ellipse to the vertex over here is a, and the vertical distance from the center to the co-vertex is b. And remember, a is going to be a larger distance than b. Here we have the vertical ellipse. The center is also h comma k. The horizontal distance from the center to the ellipse over here, the co-vertex, is b, and the vertical distance is a, and that's from the center to the vertex there. Finding the foci. C equals the square root of a squared minus b squared. Note that in this case, a represents the hypotenuse of the triangle. So we have this triangle here. From this co-vertex to the center, we have the foci in blue here and here. A equals 5, B here equals 4. Therefore, C equals 3 if you plug it into this equation. Therefore, the coordinates of the foci are 0, 2 and 6, 2.